I say, well, you should not panic and run to the hills. But what we're seeing happening in the ice sheets today is a serious concern.
If the present meltdown continues unchecked, our planet will turn into something unrecognizable. Already, the average temperature is hotter than it has been for 1,000 years. It's getting warmer at a faster rate than ever. Many scientists believe that it's due to man-made climate change, but some point to the Earth's natural rhythms. The only way to discover what's going on is to study Earth's past climate. During the 80s and 90s, an international team of scientists went to the poles, where the history of Earth's climate is preserved in the ice. Richard Alley was part of that team. Today, he's one of the world's leading glaciologists. To Alley, ice cores are like time machines. They let him reconstruct climate changes from Earth's distant past.
If you go to Greenland or Antarctica or a mountain glacier and you drill into it and you pull up a stick of ice and you look at the ice, the first thing you'll see is that it will have layers. Then you can go summer, winter, summer, winter, summer, winter, tell how much it snowed, tell how old it is.
Ice is a treasure trove of information. The layers not only tell us the ice's age, they also preserve dust from volcanoes and sand from drought periods. They can even tell us what the weather was like.
And so there's anything in the atmosphere is there, and you can measure it, including the atmosphere, how much CO2, how much methane, what were the greenhouse gases doing.
The concentration of different isotopes of oxygen in the ice cores can tell us how temperature fluctuated in the past. Plot ancient temperatures against ancient levels of carbon dioxide from the ice cores, and the cause of our present crisis becomes crystal clear. The charts show two things. First, CO2 levels are directly related to temperature. Second, today they are rising fast. Carbon dioxide is one of the main greenhouse gases. These gases trap heat radiating out from the Earth's surface. The heat stays in the atmosphere instead of traveling out into space. The result is global warming.
So carbon dioxide is rising in the atmosphere now. What will that do? Well, we're pretty sure it means it's going to get warmer, okay? And here's one piece of evidence for that. We are looking in blue at temperature in Antarctica, and then in red at carbon dioxide in the atmosphere from 440,000 years ago up to today. In blue, we see the great ice age cycle of temperature. It was warm and cold and warm and cold and warm and cold and warm and cold and warm, which is linked to features of Earth's orbit. Things that tip the pole so it gets more sunshine, wiggles in the orbit, changes in the shape of the orbit, and the beautiful pacing that one sees is the features of the orbit. Now, what's weird about that is that Antarctica's summers were getting a lot of sunshine when it was cold. And that's been really hard to explain. Why do you get more sun and less warmth? And the answer is in the carbon dioxide. When it was cold in Antarctica, carbon dioxide was low. When it was warm in Antarctica, carbon dioxide was high. So as we see carbon dioxide rising, we expect warming.
The link between carbon dioxide and temperature is ancient. But today there's a difference. The present surge in carbon dioxide isn't just due to natural processes. It's also due to us.
1850, the Industrial Revolution turns on, and we start to see CO2 going up. We're burning fossil fuels, we're cutting a lot of trees, CO2 is rising. And it's still going up, and we're burning, and we're right there. And the change that's happened is very real, it's very clear. We know where it came from, we know what happened. There's no question that we've changed the atmosphere. These are possible futures. Will the economy grow like crazy? Will the economy tank? Will we clean up? Will we not clean up? All of these projections show that the change that's coming is very big compared to the change that's happened. All of them are still going up as we cross the year 2100. The world does not end in the year 2100. And so we have made a difference. We're going to make a bigger one.
If we do nothing to reduce emissions, carbon dioxide levels could rise by an average of 30% over the next 50 years. This could result in an average temperature increase of almost 10 degrees Fahrenheit. If this trend continues unabated, by the end of the 21st century, our planet will see higher temperatures than at any time for the last million years. As our planet becomes more crowded and polluted, understanding the forces that are driving climate change becomes ever more important. Until recently, no one knew how soon Earth would reach meltdown. Now, new evidence from organisms that died many thousands of years ago suggests it may be sooner than we thought.
From wildlife reserve to domestic surrounds, Nat Geo Wild joins Michaela Strachan in this brand new series telling real stories of real rescues. But it's not always easy being on the front line.
I've got my hiding space. I've put my glasses on for protection.
It can be a messy job.
Oh, nice. I guess I am standing in a really stupid place.
Animal Rescue Squad, weeknights from 7 on Nat Geo Wild.
It can take months of preparation and days to ascend.
There is a line that once you've crossed over it, you really are beyond help.
There will be hours in freezing temperatures.
You begin to lose any touch with the reality of what's going on around you.
But it only takes a second.
Your judgment gets clouded.
To let someone die.
Yes, you're above 8,000 meters, but does it absolve you of being human?
The Dark Side of Everest. Part of Everest No Turning Back. Sunday from 8 on Nat Geo Wild. The Indonesian island of Komodo. Home to the world's largest lizard. The Komodo dragon. With serrated dagger-like teeth and a lethal concoction of venom and bacteria. This confirmed man-eater can kill in one bite. Killer dragons on Nat Geo Wild. Life in the Arctic isn't a breeze. Nat Geo Wild is heading to the Icelands to join in the trials and tribulations of life and realize it's not all fun and games. From polar bears to penguins, you'll find them all every weeknight this week in a fun-filled hour of mishap and mayhem in Ice World. Only on Nat Geo Wild.
Most of the time, the sea is our friend, a place to relax, to buy property. It's estimated that within 3 decades, 75% of the world's population will live in the coastal zone. A century from now, cities from Shanghai to New York could be beneath the waves. The problem is ice. Icebergs, mountain glaciers, the huge ice sheets of Greenland, and Antarctica. All of them are melting.
If our ice melts and the coast moves way inland, our cities will be reefs, and we will not be terribly happy with that.
Not all melting ice is a problem. It all depends where the ice is. If the melting ice is already floating on the sea, it doesn't pose a threat.
There's lots of ice on the planet, and only some of it raises sea level when it melts. So let's see what happens when we get too much heat on floating ice to start with. The level has not raised. Melting floating ice does not raise things. The ocean is not going to get filled up that way. But what would happen if we melted the glaciers of the Alps, the glaciers of Antarctica, or in this case, let's call this Greenland? What's going to happen if the heat turns on to Greenland and we start melting it? We could even have an iceberg break off of the side of Greenland or two and fall in. There's a couple falling in right there. And now what's going to happen when we're melting, when we're calving, when we're putting more in? And the answer is in. If you melt Greenland, or if Greenland flows faster and starts dumping more icebergs into the ocean, it will raise sea level. If we burn all the fossil fuels, if we raise the temperature a lot, if we melt Greenland, that there's